Hey, what's up? Last Layer King here. Today I'm going to be going over Perm Parity. If you haven't already seen my video on triple weak swap and 5 style, then go check that out because I'll be using triple weak swap in this video. So if we take a look at this position here, you'll notice I have all but one corner target solved. So this position has parity. So let's see what happens when I solve edges using weak swap. So I use a UB buffer, so this piece is going to go to here, and we've hit the buffer, so we're going to weak swap it to here. And then we have buffer to here to here. And now we've hit the UL piece, so we're going to weak swap the UL piece to UF. So we have here to here to here. And I'm going to the side because the piece is misoriented and I have a side color in my buffer. And now I've got the UF piece in my buffer, so I'm going to weak swap it to UR. So we have buffer to here to here. And now I've got the triple weak swap set up with the buffer piece in UL, the UL piece in UF, and the UF piece in UR. Now if I do buffer to here, we'll see that I get the UR piece in my buffer. So now we have this Perm. So essentially, this is Perm parity. So instead of having a UB-UL swap or some other swap and one corner target, we have an Perm and we have one corner target. This will occur on half the solves in which you do triple weak swap. The other half the solves won't have parity and you'll be able to do 5 style. Basically, this is just going to be an algorithm set which will solve the Perm plus any corner target. There are 21 possible corner targets, so there will be 21 algorithms in the algorithm set for Perm parity. I'm going to go over some of the algorithms in this algorithm set because a lot of the algorithms are very easy. So with a UBL buffer, if your corner target is here or here, you'll find that the algorithm is just going to be an Perm with an AUF. If your corner target is here, it's just going to be an AUF and an EPerm. If the corner target is somewhere on top but it's misoriented, then the algorithms are just going to be ZBLLs. This case has the corner target here. This case has the corner target here. And these ZBLLs are actually the same. This case has the corner target here. This case has the corner target here. And these ZBLLs are also going to be the same. This position has the corner target here. This position has the corner target here. And you'll find that these ZBLLs are also the same. So instead of having 6 algorithms for the other corner targets on top, there's really just 3 ZBLLs, each of them from 2 different angles. If the corner target is on the bottom half of the cube, but the piece in the buffer isn't the bottom color, there is a very simple way of solving all of these cases. You'll notice that with the Perm, if you do a U move, all of the edges are now going to be solved, and what we have is a 5 style case for corners. So the comms you would use for these cases will be similar to how you would do CP with comms on Megaminx. So this piece is going to need to go here, because if we look at the 2 colors, other than the top color, we have orange and blue, and it's going to go between the orange and blue edges. So our insert is actually going to be R prime, D prime, R, to move it to the top, and it's going to go to this location. So we need to move this location over so that it inserts into the right place. So we'll do U prime and then insert. And now we have a corner here, this one being red and blue. So we have blue here and we have red here, so the corner needs to go here. So we'll do U, and then we'll undo the insert. And here we've got the red and green stickers, and between red and green we have this corner, so we'll do a U to move it over. Insert. And then this piece now goes here. So we'll do a U, undo insert, and then we'll fix the top. You'll find that when doing comms like this, all of the U moves between the inserts are going to be U moves. And that is just because of how the Perm is set up. So for this specific case here, our target is here, and we can insert with R, D, R prime. But we see that we need to actually insert it here, so we're going to start with the U2. And then we can insert, U, undo insert, U, insert, U, undo insert. So all the algorithms for these cases are going to be insert U, undo insert U, insert U, undo insert, with some AUFs, and potentially some ADFs. Here's another one where the target is here. So we can get this piece to the top by moving it over, and then R prime dr. But the piece actually needs to go here, so we're going to do a d prime u prime to start, and then insert u, undo insert u, insert u, undo insert, and then we can finish with u prime d. The other cases should be pretty easy to figure out. You'll find that these types of algorithms are extremely fun to do, and it is very easy to get a high TPS on them. If the sticker in the buffer piece is the bottom color, then solving this with comms is not going to be as efficient, so there will just be a set of algorithms for it. If your buffers are UF and UFR, you'll find that the O-perm is still going to be exactly the same, and the algorithms are going to be extremely similar. Let's do some example solves. I'll put the scrambles in the video. Scramble in your orientation, but if your buffers are UF and UFR, scramble a Y2 away from your orientation. So here we've got buffer to here, and we've hit the buffer piece, so we're going to weak swap it to UL, so it'll go to here. This piece goes to here, and now I've hit UL, so we're going to weak swap UL to UF. So this will go to here, which goes to here, which goes to here, and now I've hit the UF piece, so we're going to weak swap it to UR, so we'll go to here. This piece goes to here, and now I've hit the UR piece. So normally we'd hit the top color, but because we hit the side, we know that there's either a flip somewhere or an additional cycle. In this case, has an additional cycle. So we'll cycle break to here, and this piece goes to here, and now we finish the cycle and we're done, and we had weak swapped this target, and this target. So we should get an O-perm at the end. I will now solve corners. And now I have only one corner target left, so I will go on to edges. So we had buffer to here, and then we had to here. So now we have these two pieces already set up like we would in weak swap. And then we have here to here. And then we had here to here. So now we have all three of these pieces set up for the O-perm. And then we had here, and we cycle broke to here. And now we have here to here. And now we have our O-perm, and our target is right here. So we're going to do a D prime and a U prime, and then we can go into this sort of Megaminx com style alg. So here is another example solve. So we've got buffer to here, which goes to here, which goes to here to UL, but we see that the buffer piece is already in UL, so it's already pseudo-solved relative to weak swap. So what we're going to do here is just double weak swap this piece to UF. So go here to here, which goes to here to here. This piece goes to here, and we've hit the UF piece. So we know there's a flip because we hit the side colored when we should hit the top. And we see there's a flip on UR. So what we can do is cycle break into this flip, and I'm going to cycle break to the side target so that when we finish the cycle, it'll end on the top target. And finishing the cycle is actually already going into the O-perm because we'll end up going here to here to here at the end. So our memo is going to be buffer to here to here, to here to here, to here to here, to here to here, to here to here. And that should give us an O-perm. Now I'll do corners. And there's one target left, so I'll go on to edges. So we had buffer to here to here. And then here to here. And then here to here. We're not touching this piece because it's already set up for weak swap. So now we head to here to here. And then we went here, and then we cycle broke into this flipped edge on the side target. And sure enough, we get an O Perm. So we can just finish the cube with the O Perm parity alg. That's it for this video, and that is about it for weak swapping edges. I don't see much point in going anywhere past triple weak swap, and I don't recommend any additional targets or cycles to set up for triple weak swap since it's already relatively rare that you'll be able to do it. In the next video, I will go over some miscellaneous tricks you can use with weak swap, so I will catch you in that video.